Pleasure to be here. What I want to speak with you about today is some of our experiences in working with particularly EDA customers in making use of cloud computing. And I'm going to actually show you make reference to a real world customer. That customer is Mellanox, a name that'll be recognizable to most of you. And just to give you a sense as to what they're doing today in production with this thing called a hybrid cloud. So our booth is just kitty corner to the stage here, and I've been able to catch sort of dribs and drabs of other people's presentations. And of course, the term cloud is being bandied about rather extensively at this event, which is a wonderful thing. And again, I do want to focus in on this notion of the hybrid cloud, and I will tell you more about what I mean about that as the presentation evolves. And you know, this picture which I've taken from Cloud Tweaks, it may have been appropriate at some point ago, but if you know anything about hybrid cloud, of the various cloud paradigms that one might start to talk about, I would suggest to you that perhaps the hybrid is perhaps indeed the most scariest. It's the one that actually takes the most effort. So, just to do a little bit of a level set, as you've heard from previous presenters like the folks from Google today, you can build your EDA cluster, your EDA engineering, virtual engineering environment entirely in the cloud. So if you like, in that kind of end member case, that's completely a public cloud deployment. But of course, people have and continue to build clouds within their own premises, maybe making use of their own data centers, maybe data centers that are located at different sites, or perhaps even co-location facilities. And they would describe what they're doing as building more of a private cloud. And they may use everything from commercial software such as VMware to open source software such as OpenStack to build those private clouds. What I'm going to talk about today, though, is something that is kind of in between those end member cases, if you like, this notion of the hybrid cloud. So we'll say a little bit about hybrid clouds themselves. I want to tell you about some work that we've done recently where we've taken some of our key technology for enabling the deployment of hybrid clouds. We've actually taken that and released it into the open source community. So I want to share that with you. I'll talk to you also about our commercially supported offering based on that open source project, something called NAVOPS Launch. I'll then share something about our actual real-world case study, which we actually have available, copies of which we have available at our booth, and just tell you a little bit about our notion of bursting, wrap up with some ideas around some deployment best practices and that kind of thing. Let me start off by saying a little bit about hybrid clouds. So this is the one sort of heavy-duty company pitch slide. I think the most important takeaway that I want you to gather from this slide is that we're really an enterprise-focused software vendor. We have built our company around the delivery, the ongoing development and delivery of the grid engine software. Okay, so some of you may have this at your own sites. You may have the open source version, Sun Grid Engine, or some variant thereof. We have taken the open source Sun Grid Engine and offer a commercially supported version called Univa Grid Engine. And that's been our core technology, and we've continued to innovate around that. We actually still have a lot of the core people who've been working on Grid Engine for, frankly, a couple of decades in our Regensburg, Germany location. We also have a number of enterprise customers, so that's really important in terms of addressing this. And of course, what really is, the emphasis, and again, you've heard, if you've been to other talks during this session, I think you've seen this question, this conundrum come up a number of different times. How do you actually embrace the cloud in some way that is, sensible to you? How do you take that and really make it deliver with the kind of performance and other characteristics that you might need? So that's really what we're wanting to focus on here. And you can see that the analysts are also sort of working in parallel in terms of their perspective, how they see a real transformation happening with software really leading the way. Now, because we have a pretty substantial customer base of order 300 enterprise customers, what we're able to do is actually consult our own customer base and ask them about their perspective on various kinds of cloud-related matters. And so I'm sharing with you a part of really a broader survey. And what you can see here, as I've said, we've got really an enterprise weighting in terms of our customer demographics. Their interest in cloud is really increasing. Now, what's of course different? There's nothing new about cloud computing. Let's be real here. What's different is people are actually really starting to try to do things in the cloud, and that includes the EDA market. And I'll talk more about the nuances that are specific to EDA with survey-related data points shortly. Clearly, there's a lot of interest in trying to embrace the cloud in some fashion, and this was part of the driving momentum, the impetus behind us deciding to take some of our core technology and release it into the open source community. And of course, there's a lot of other things that are going on as well to aid us here. Again, in some of the previous talks, you've heard about such things as containerization and building applications that are cloud native, perhaps making use of different architectural paradigms, trying to introduce more microservices-based architectures and so on. There's really a lot to consider, and we kind of put a lot of this newer thinking, which may, for example, involve use of Kubernetes container clusters into the notion of cloud-based HPC, cloud-native HPC. So, by and large, when we consulted our customer base, most of them are making use of AWS. And this is, of course, it's not entirely surprising. AWS has been around for basically the greatest amount of time they've had. So their offering has matured very, very nicely, and we certainly see that in terms of the adoption. Very interestingly, the second major group that is really seeing great growth is in fact Azure, Microsoft Azure. So we've actually, and in fact the case study that I'll highlight today is an EDA company making use of Azure. And also in there, of course, is Google, and to a much lesser extent, and definitely more the newer kids on the block is Oracle. You can see that people are taking a variety of different applications and trying to take them into the cloud. Everything from traditional HPC applications, which would include some of your EDA applications. And again, we'll be a bit more specific as we drill into this a little bit more here, but also we're seeing uptake in terms of artificial intelligence, deep learning workloads, which our customers are also doing, and various other miscellaneous big data workloads. Now, when it comes to industry adoption, because Univa doesn't just play in the EDA industry, we actually have representation in a wide variety of different industries. If you can see the details here, that's clearly evident. What is out in front in terms of adoption is very much industries like the life sciences and government and education. They're the upper bars in this slide here, if you can't see the fine print. Even aerospace is ahead of EDA. So we've got something very interesting going on here, because I would submit to you that probably if we were to look at the our numbers of customers by vertical market, EDA would probably be, if not the biggest market that's represented, very, very, very close to that. And yet EDA has not been the fastest mover to the cloud. And certainly other presentations have touched on this point as well. Why? Well, there are all kinds of different reasons. Again, I will only go over this fairly quickly. This is coming from, again, our customer base in terms of their responses. And you've heard about this if you've been through some of the other talks here. I think you've heard about a lot of these other reasons before. Security, of course, is always an interesting one, and we heard some great counterpoints in the previous speaker's presentation from the folks at Google. Data is one of the most interesting challenges that also has to receive significant consideration when it comes to cloud migration. And there are various other factors as well. Notice also expertise within the teams that are already involved in perhaps providing other kinds of infrastructural services is a factor here. In the project that I did with Mellanox, for example, as would be typical of any enterprise, when you start embracing the cloud and you want to start trying to do things, you need to get the networking guys to show up, the information security people to show up, the storage people to show up, the applications people to show up. You know, everybody, the entire ecosystem needs to be represented because your cloud project will touch potentially on all of those different areas. So what are the drivers then? Even though we have some challenges, it's acknowledged, what is causing people to take some consideration of actually trying to embrace the cloud. So let's focus in just on the EDA piece, because that's the focus of DAC here. Seems to be easier when we spoke with some of our smaller to medium-sized EDA organizations. They had typically less in the way of legacy IT infrastructure considerations to think about, and so it was easier for them to have some motivation to move to the cloud. I certainly find in my travels a lot of demanding users on the engineer side, and so this can be a real driver for helping to make the case to move to the cloud. And let's face it, of almost any market, you folks know all about the importance of time to results. You have unbelievable valleys and peaks in your design cycles that are relating to the various projects that are competing for infrastructural resources and so on. It's just not practical to provision an environment for the peak workloads, and therefore this big disparity potentially. It's potentially significant disparity between perhaps the norm and the peak around tape out time kind of thing. Really does help to make a very practical case, and I'll come back and touch on that through this real world example a little bit later on. So we're going to focus in, as I said, on hybrid cloud. So the idea that you have some kind of a presence on premise, maybe it's a very, very significant data center, and the idea then is that companies such as Mellanox are interested in trying to complement their existing on-premise deployment with resources that just happen to be based in the cloud, okay? That's really what our emphasis is in this talk, although the kinds of solutions that I'll describe to you are able to deliver on public cloud, private cloud, and hybrid cloud configurations. So let me tell you a little bit about Project Tortuga. So Tortuga is something that we've very recently released into the open source community. You can actually get it on GitHub. I'll give you a link for that in just a moment. It's basically a general purpose framework that allows you to basically build applications, to manage the cloud-based infrastructure, and it's all about automating. You can see in the fine print here, the detail here, and I'll tell you a little bit more about some of the internals, but basically what it includes is a lot of the automation pieces. We make use extensively in Tortuga of something called Puppet. Some of you may be very familiar with that. It gives us the ability to do configuration management, and we build around that. The way we're able to support different cloud infrastructures is through the notion of these entities over here that are called resource adapters. So we have a resource adapter for AWS, and one for Azure, and another one for Google. And indeed, you can actually build different adapters yourself. So this has all been made available, as I say here, in the open source community. It's made available via this fairly liberal Apache 2 license. What we've made available is basically the core technology itself, as well as adapters for these different cloud-based environments. So you can actually go get this from GitHub, download it, build it. We give you all the instructions to do this, and you've actually got adapters for all of the major cloud providers ready to go. Also, what's included in the framework is something that we call our policy engine. The policy engine is another place where we take automation to the next level. And as you'll see, it's really at the heart of the dynamic, making our cloud bursting policies highly dynamic, which is what customers seem to be demanding. You can pair this with various other offerings, open source or others, and so on. We have, of course, provided an integration with Univa Grid Engine, and you can get a trial kit from us that includes our Unisite product, which provides monitoring and reporting capabilities as well. So all of this is, it's been available for a couple of months now. Now, you may be thinking to yourself as you sit through talks here, as you walk around the conference, that maybe what you'd like to do is just do it yourself. Okay? So what would that actually involve? You can think about what would be involved in terms of the effort that you might want to put into this. And I would submit to you that what you probably find is that as you built your solution, what you'd build is basically a prototype, which is working to some measure of degree, basically a one-off. So if you took somebody who was really fairly competent at this kind of thing, had some cloud-based expertise, some HPC expertise, maybe knew a little bit about the EDA vertical market, we estimate that it would take just shy of about 100 days to do this yourself. So it's a fair bit of effort that's actually involved. And if you were to try and do this the way we have for multiple cloud providers, so being able to support the likes of, say, Amazon and Azure and Google, that you're probably looking at some time that's well in excess of a year, maybe a year to possibly even as much as a year and a half. I would submit to you those are pretty reasonable estimates. So doing it yourself could be quite an undertaking, and that's partly why we decided to go with releasing Tortuga into the open source community, because part of what we're trying to do here is actually increase the amount of adoption, awareness and adoption, particularly of hybrid clouds across a number of different vertical markets. So doing it yourself is certainly possible, but probably take quite a bit of effort. Let me now transition from this open source offering to our NAVOPS Launch product. So this is basically the commercially supported cloud automation enablement piece available from Univa that builds on the Tortuga framework. So this is a kind of a full sort of set of our available products at the current time. So for high performance computing, many of you will know us for Grid Engine, Univa Grid Engine. That remains the core technology on the HPC side. And as I alluded to before, we've added monitoring and reporting capabilities through our Univa Unisite product. If you're interested in making really effective use of your expensive software licenses, which for many of you would probably be your most valuable commodity in the EDA industry, we have something called our License Orchestrator product. And this allows you to work with FlexLM and actually share your licenses in various interesting ways, possibly even across different geographic boundaries and so on, so that licenses can be properly managed as a very effective resource as well. Over on the NAVOPS side, you can see that NAVOPS Launch is our key technology for being able to make use of cloud-based resources. And we've also, for those of you who are interested in basically container clusters built on Kubernetes and so on, you may find it interesting to know that one of the things we've done is we've taken the smarts of the Grid Engine scheduler and we've effectively stuffed that into a container, a Docker container, and you can actually make use of that as a scheduling capability that augments the innate scheduling capability that exists within Kubernetes. And finally, if you want to introduce various Mesos compliant frameworks, we've also got an offering called Universal Resource Broker that speaks to that side of it as well. But again, our focus here is on cloud, and so I want to say more about NAVOPS Launch. So Launch, as you can see, is all about deploying and managing HPC clusters on an ongoing basis. Our emphasis today is very much cloud computing. It's very much hybrid cloud computing, but believe it or not, this product does actually work with physical servers in your data center as well. So it actually spans the gamut there in terms of those kinds of capabilities. And what it really allows you to do is automate the management of potentially the entire grid engine infrastructure. The key capabilities that we'll highlight through the case study have to do with introducing policies for when we decide to make use of the cloud, so that the use of the cloud can be very strategic. Because of course there are a lot of considerations to keep in mind there, for everything from cost to flow of data and various other things as well. Now, because we've been working in the HPC space for such a significant amount of time, we're also extremely aware of what HPC customers, which of course EDA customers are, what they require. And that's taken into consideration in the solution that we're offering here. And also, what I think is very nice about the product is we don't actually come in and say, okay, we have to start and take over your entire infrastructure from bare metal. We can actually work in a real enterprise, which we call a brownfield deployment. Okay? We realize that the enterprise can be a very complex place. So this product can actually be introduced in a very strategic way, as I'll start to share with you very soon here. The schematic in the lower right here, which is probably not very readable, what it's actually showing is the core of the product of NAVOPS Launch. The product has a REST API that is available. We're almost finished building a graphical user interface. There's an existing command line interface, and then I also alluded briefly to the further automation through our notion of the policy engine. And then this cloudy-like bubble that you see up here in the right-hand corner, that's showing you that we have all these adapters for different cloud providers, and that's not even a complete list there. All right. Well, now things get interesting. So here's one of the ways that we start to have our discussions on hybrid cloud. So in the upper part of the diagram here in the rectangle, this is your on-premise deployment. All right, so that could be your potentially very, very significant data center. So in the example I'm going to share with you today, the example from Mellanox, they have a very significant on-premise data center at one of their sites in Israel. So that means that their grid engine queue master, the brains of the workload manager, resides on-premise. Now, what's very interesting in the hybrid case is people have different requirements. So this particular customer, along with some of the other customers that we have in other verticals, have said to us, look, we have standard operating procedures and processes in place for taking care of our on-premise compute resources. We can manage the on-premise stuff fine. When you introduce NAVOPS Launch, what we want you to do is only take care of what's happening in the cloud. So NAVOPS Launch is actually flexible enough that it can do that. So in this particular example, the NAVOPS Launch is only managing cloud-based compute resources. So here's just a representative cloud-based environment. Basically, NAVOPS Launch works with whatever is provided to us by the cloud provider. We use whatever API or APIs are available. So it's going to be different for AWS, different for Azure, and different for Google, etc. And that's fine. We take care of that for you. This is part of what's in the guts of that resource adapter that we were talking about before. We work with you when it comes to the connectivity. Some of our customers, if they've got a very significant deployment, for example, they'll have an uplink from their on-premise data center into their cloud provider or providers of choice. Some people just have a persistent VPN of some fashion that is deployed there. So again, it depends on what your requirements are. I'll only say very little about data. It's one of the most interesting discussions we have. Obviously, it's one of the biggest challenges, and it's something that has to be part of the consideration. I'll say a little bit more about that as I get into the specifics of the example from Mellanox, which is next. Okay, so basically, as you would expect, this is a typical EDA customer. These, if you haven't heard of Mellanox before, they are designing the various silica that is behind various kinds of interconnect solutions. For HPC, they have basically the industry-leading InfiniBand solution. They even do Ethernet-based solutions as well. So very much a typical EDA company doing simulation verification. And what they were finding is that they were running out of compute capacity at peak periods in a pretty significant way. So they had the option. They actually had space to deploy an additional data center or add additional servers to their on-premise data center environment. But this project had visibility right up to the CIO level, and they were very interested in actually tapping into the cloud. And what they were finding, of course, was during these peak periods, they were having challenges around license utilization and so on. So we worked with them. They first of all replaced Sun Grid Engine, open source Grid Engine, with Univa Grid Engine, and then they've been strategically adopting the cloud in a very systematic fashion. And I'll give you a bit more of the detail, the color on that. And so the value that comes back to them is that they are able to take advantage of the peak capacity that's delivered to them via the cloud when they have these extremely busy periods. And as you're going to see, they did something very interesting. They actually have a functional verification application that they've written themselves. So they actually have the code for a functional verification application, something they use extensively. It's also an application that's been parallelized, so they can actually run it on multiple threads. So because there weren't any licensing complications to deal with here, and because for this particular application, most of the time the volumes of data on input and output that needed to be moved around were pretty minor, they thought this was a perfect application to prototype their use of the cloud with. And so that's what they actually went with. And so, sorry, just to complete that part of the story, what that means then is at these peak periods, they take their functional verification applications, they basically divert them off to the cloud using the solution that we put together collectively, and that freed up on-premise compute resources. And then for those on-premise compute resources that were freed up, they were able to take advantage of their existing EDA tool set and their license tools and get more effective use of both the licenses and the on-premise compute resources, even during these peak periods. Well, this is a schematic from Mellanox themselves, and I'm not going to go through this in tremendous detail here, but this gives you a bit of their thinking. You can see again, over here on the left is the on-premise environment, and over here on the right is the cloud-based environment. So most of the workload management infrastructure is on-premise. And what they needed to do was basically make replicas of some of their EDA tool chain in the cloud, and they made use of NAVOPS Launch to spin up compute nodes in the cloud in an on-demand fashion. They decided to actually have various services persistent in the cloud. So they had basically a modest NFS server that was able to provide some of the EDA toolchain functionality in the cloud. The other thing that they did was they actually built custom software images for the virtual machines that they would use in Microsoft Azure. So very pared down images that just had on them the operating system and whatever their functional verification application actually required. So basically some libraries. Very, very lean. And they used this when they provisioned virtual machines in Azure. So here, again, I apologize for the eye chart. I will basically tell you the idea here as to how they decided to put things in place here. One of their requirements was they wanted the introduction of the cloud to be as transparent as possible to their engineers. So that the engineers didn't really need to worry about, where is my job running? Is it running on the cloud? Is it running in the data center? Or where? So what the engineers did was they continued to submit jobs in the fashion they were accustomed to. And then Mellanox wrote a little script that would look at the pending job backlog in the Grid Engine environment and figure out which jobs they might want to opportunistically take advantage of the cloud for. They'd switch those cloudable jobs, those cloud-friendly jobs, if you like, to various queues. And then, once those queues started to build up a bit of a backlog of jobs, our NAVOPS Launch software, which was basically monitoring for this situation, once the backlog got to be, say, 5 jobs deep or something like that, NAVOPS Launch would automatically start to spin up virtual machines in Azure. Once the machines were ready for use, Launch would automatically let the Grid Engine environment know, hey, you've got some additional compute resources. And Grid Engine would schedule those functional verification jobs to those virtual machines in the cloud. Their sophistication was even more advanced because they actually had, as I mentioned before in passing, this functional verification app that they have is very scalable. It's implemented in shared memory and can run on multiple threads. So what we worked on with the folks at Mellanox to achieve was basically to have 2 kinds of classes. Jobs that were very highly scaled, basically made use of 20 cores, so 20 threads in shared memory at a time, or up to 8. And then Grid Engine would basically take care of scheduling the jobs to the right machine. So they had this completely set up and integrated, and this is all actually running in production at this particular time. So when I worked on this project with the folks at Mellanox, we used the policy engine that was built into NAVOPS, ultimately Project Tortuga, something you can get through the open source community. And basically it's an XML-based rules engine. It's if you're not, some of you work with various kinds of programming languages. I'm sure you're not too scared of XML, but we realized that there was actually an opportunity to take this to the next level. So in fact, what we've done is we've been able to take this paradigm for cloud bursting and refine it even further. We have a product called Univa Unisite. One of the recent additions to Univa Unisite is something that we call our rules engine. So now you can actually build your rules for cloud bursting using a template that looks like this. And we can, of course, set you up to take advantage of this. So here, for example, is one of the rules that's this is the rule that actually adds compute nodes when there is a demand. This is the one that takes them away, basically finds nodes that aren't processing any workload, shuts them down, and basically all of this is rendered available in terms of various kinds of alerts that can be displayed to the screen or can be sent via email, etc. So we've taken the cloud bursting paradigm that we've already employed for Mellanox and actually refined this, and people are actually starting to look at this. There's so much more I could tell you about this, just some lessons learned along the way. It seems like cloud projects, there is no one size fits all, there are no 2 that are identical. Always good to have solid business drivers. Mellanox had a very compelling business case along with the technical side. You really have to have both. You also need project management. Things can get interesting. You know, sometimes you're working across multiple time zones, and that can be a challenge. And, all kinds of other things here. focusing on a single application, as Mellanox did. They had a perfect candidate application in their in-house functional verification code. So I think that was a really good decision. They also had a test environment that we were able to try everything out in before we put it into production. That's another very good idea. Have a complete scaled down test environment so you can try things out. These kinds of things probably should be mandatory. So this is the paradigm that I'm speaking about in terms of working towards a really what I think will become more of a prevalent paradigm in EDA. And just to show you, because I know some of you, we have customers, some of which are name brands right here on the show floor that are literally pumping millions of jobs through their cluster on a daily basis. I want to also underscore the importance of the scalability of the solution here. So we've actually just published a blog post this week where we talk about our 1,000,000 core project. So we deployed 1,000,000 cores in AWS. It took about 2.5 hours. We did it across 3 different availability zones. We used some of the additional sort of spot instance capabilities that are provided by AWS. We deployed 16 different types of images, of instances, compute instances. So you can mix and match compute instances. Sometimes you need big memory servers. Sometimes you need maybe servers that have very high-speed disks attached to them. Maybe you need GPUs, not a problem. We can do all those things. So we did all of that. And so in this particular case, 1,000,000 cores, over 1,000,000 cores, north of 55,000 compute instances in AWS. Okay? 1 grid engine cluster, all in a single grid engine cluster. So you can Q-sub your way into extreme compute capacity and or capability. So what I've tried to share with you today is some of the work that we've been doing and making reference specifically to the hybrid cloud case. We see this as a real growth area. We are receiving things have gone, they've gone, quite ridiculous in the last little while. We're just fielding so many inquiries about interest in hybrid clouds, not just from EDA, but across a number of different markets. We're trying to help the adoption of this hybrid cloud paradigm by releasing our open source framework project Tortuga into the open source community. It's there, you can get it from GitHub. We've also got an enterprise grade offering called NAVOPS Launch that we're using in real EDA customer deployments, and I gave you one, I think, pretty compelling proof point using Mellanox technologies. And we actually have copies of our case study with Mellanox available at our booth, which, as I said, is just outside here. They are doing cloud bursting today. There are additional capabilities for refining this further. And as we work together, because this is very much a partnership, Univa works with the customer, perhaps with industry experts, and definitely with the cloud provider. The solution we put in place for Mellanox was very much Mellanox, Univa, Microsoft Azure, all working together to realize that ultimate result of a production deployment. And we're starting to amass a pretty impressive set of resources. I'm sure we'll make slides available in one way or another. Our example with Mellanox is just one. We've got another very interesting case study with the Wharton School, and it just kind of goes on from there. So it's been my pleasure to share a little bit of our story with you today. If you have time, please come and visit us. Our booth is literally just right over here. Copies of the case study are hopefully are still available. We'd love to chat with you. And I think, do we have any time for questions? 1 or 2 questions, if anybody has any. He's going to give you a microphone.
Hi, in this particular case, why not burst out all of the work to the cloud instead of just the access?
So the question is, why not push all of the work to the cloud instead of the XS? Well, we certainly have customers who are doing that. You know, it's really whatever makes sense from both the business and technical perspective. In this particular case, this customer, you know, as we see, the hybrid cloud paradigm is pretty prevalent in enterprise customers because so many of you have existing on-premise deployments that are pretty significant. So you want to make use of that, you want to make use of all the effort that's gone into that, and then just sensibly make use of the cloud. So it really comes down to, you know, whatever makes sense to the customer. We have people doing all kinds of different things.
May I know what's the license scheme for this?
The licensing?
Yeah.
So the licensing is for Univa, you pay a traditional license for Univa Grid Engine, which is basically based on number of cores that you're going to use, and then there is a basically pay support for NAVOPS Launch. So it's kind of a Oh, right. So obviously, you know, we're not giving you a way to circumvent any of the other licensing, you know, paradigms that are already in place. So if you were going to run some simulations in the cloud and you wanted to use licensed software, you'd need to be able to access your licensed server and check out tokens the way you do on premise. So we're not. In the hybrid cloud environment, what we're seeing people being interested in doing is, you know, tapping into their existing on-premise deployment, but just happening to run some work in the cloud.
Okay, so we have to maintain our own license server.
Yes, okay. Yes, yeah. We're not. I guess Cadence has been talking about kind of a full service setup for their solutions. We're not doing anything like that. No, you'd be tapping into your existing enterprise case, which is what companies like Mellanox will do. That's what makes the most sense in the hybrid case.
So how can you enhance security?
How can we enhance
the security?
Oh, the security. If I gave you the impression that we are doing that, then I may have misled you. We're not a security-focused company, okay? So what we typically see is we see, you know, customers making use. In some cases, as I say, people have direct uplinks into these cloud providers. So whatever security you're building around your existing network infrastructure is something you can extend into the cloud, right? And then, of course, there are, of course, all kinds of cloud-based security considerations, which again we've been hearing about from some of the other the cloud providers, and so that's going to be something you'll have to discuss with them on a provider-by-provider basis. We're not a security company. We work with the existing security paradigms. Yeah. Thank you for the question. Okay. Great.
Yes.
Thank you. Thanks very much.